In this new video, we're going to take a look at the wave nature of light. Now, we've talked about light being composed of small packets of electromagnetic energy. We said that each one of these packets of energy were called quantums way long ago. And in modern days now, we call them photons. So we say light is composed of small particles called photons. But we've also talked about the inverse relationship of frequency and wavelength. And in those examples, we talked about light moving as a wave. In this section, we're going to stick to that type of idea. We're going to see light as moving not as individualized particles, but rather as a wave. And we're going to say there's an equation that shares this relationship of light moving as a wave. It's called the de Broglie wavelength equation. So de Broglie wavelength equation. And under this equation, it says light moves as a wave, not as individual photons, individual particles. Now, we're going to say to calculate the wavelength of matter, we simply use this equation. Now, the equation is for the de Broglie wavelength equation is lambda, which is our wavelength, equals h, which is Planck's constant, divided by m times v. Now, we know that lambda is wavelength in meters. H is Planck's constant, which we've talked about. Here, m represents the mass of the object we're talking about. Usually this object is a subatomic particle. So here it'll be the mass in kilograms, not in grams. And then v here, v does not represent our frequency anymore. V here is actually velocity or speed. And velocity or speed are in meters per second. Now, what we need to realize here about Planck's constant is 6.626 times 10 to the negative 34 joules times seconds. And we should realize that joules can be written in a different way. Joules also equal kilograms times meters squared over seconds squared. That's what joules equal. And if our joules are still multiplying with those seconds, then those seconds will get canceled out with one of the seconds here. So in this equation, we're going to say Planck's constant becomes 6.626 times 10 to the negative 34 kilograms times meters squared over seconds. So just realize how those things canceled out to give me that. So those are the units you're going to have to remember when it deals with the Broglie wavelength.